All right, calculus. So, sorry about that. Going to make a quick video for you here. Again, so that quiz number 1, which you were going to take yesterday, obviously didn't happen. Whenever we get back, we'll be taking this quiz the second day back. All right. So what you guys just gotta make sure you have is that you have this review, that you have all these answers. You might have 2 of these. Okay. So just make sure you've got it. Anyway, I believe, I don't actually know if I printed this off for you, so that's why I'm just going to make a quick video here with the answers, okay? Like just showing you the answers. You know how to do this. I don't need to explain any of this. So just pause it, get down those answers. These are all integrals with no bounds, so you got the plus C. And then for your you can do homework set 2. You can do it all right now, and that's what I would concentrate on. I'm about to put up, whether it's tonight or tomorrow, some videos going over section 5.4. That is the new, again, this is like 5 times 1 over x, so that's why it's 5 natural log x. I'm going to put up the first of 2 videos for section 5.4, which we started, I think, the other day. Just wrote down a definition. Anyway, my goal is to show you section 5.4 and 5.5 through videos. Again, it is not really what I want to do. You need to evaluate this. Okay, so I just found the antiderivative, and then that's the antiderivative evaluated at 3, antiderivative evaluated at -2. So good luck there. All right, that's the antiderivative evaluated at 3 minus evaluated at 1. There we go. Antiderivative evaluated at, obviously, 0 minus evaluated at -3. Okay, pause this whenever you need to. You need to FOIL that sucker up, and then evaluate the antiderivative at 1 minus the antiderivative evaluated at -2. That is the fundamental theorem of calculus, part 2. You already know it. Part 1, though, it's pretty easy, but when we first learn, it's a little bit tricky. Again, pause those videos, really take your time with the notes. I'm going to do the best I can. I would like to show you calculus in person, so this is going to be new for me, too. All right, there we go. Evaluate the antiderivative at 2, then 1. Then evaluate the antiderivative at pi, then 0. I did that one for you. I had enough room. Evaluate the antiderivative at pi 6, and then a -pi3. Evaluate the antiderivative at pi 4ths, and a -pi6. I did that one for you. That would just be whatever cosine is, the reciprocal of that, all right? And for that sucker up, evaluated at 3, then at -3. A particle moves along a line so that its velocity at time t is that. Now, the displacement's easy, all right? Find the displacement of the particle during the time period 1 to 4. That's not the distance traveled. Remember, the distance traveled is always positive. Displacement is just velocity. Take the antiderivative, evaluate it at, s of 4 minus s of 1? And then whatever that is. Find the position function. It's just the antiderivative of that plus c. All right. Then, same question with find the position function. Find the displacement of the particle during the time period 1 to 6. Take the antiderivative of velocity. Evaluate it at 6. Evaluate it at 1. Displacement can be negative. Distance traveled cannot be. All right, so that quiz will happen the second day back from whenever I see you. All right, so this is the last homework set you have in your possession, the integral homework set. I'm going to call it Chapter 5, homework set number 3. Now I'm going to give you a video here probably early next week. I mean, there's no rush. We don't have to. Your goal is to learn, you know, do the second homework as best you can. look at quiz review number 2. I'll put up a video this week. And then get down the notes really well for 5.3, 5.4. There's no reason to give you a video for 5.5 this week. So maybe Monday or Tuesday. Anyway, we got to use substitution. And you don't know what that is right now. And you will shortly. So number 1, you can't do. Number 2, though, you can definitely do. It's just a regular antiderivative. Just do it. Plus C will be involved. Okay. And number 3, believe it or not, you can just do it. Put the quarter out there. Again, you know how to take the antiderivative of e to the 3x. Number 4, use substitution before. You don't want to multiply x plus 1 8 times. Use substitution on 5, so don't do that one yet. Just do this one, okay? You guys got it. Remember, you know, it'd be negative 6 cosine a quarter x. If you're taking the derivative of this, you would multiply by a quarter, but the antiderivative, you'd do the opposite, okay? And 7, use substitution time. 8, use substitution time. That would probably be a beginning one for us when we talk about use substitution. Integration by substitution is what it's called. You guys got the Google machine. You can look up a few things. Khan Academy, I'm sure, has some stuff, but I will also give you a lot of examples via Yak Math videos. Use substitution time. Again, we want to integrate everything. There's tricks for derivatives. There's tricks for integrals. You can do that one. Just do it. Remember, this one has bounds. Okay, so 9 has bounds. 10 does not have bounds. 11 has bounds. 12 has bounds. Use substitution time with 12. Next page. All right. Next page. I would FOIL it and just do it. Has bounds. Use substitution time. Definitely. Don't want to multiply that out 7 times. Ooh, 15. So I'll give you an example of how you can maybe, you know, if you want to see like, oh man, can I take the derivative of that? Test it out. But we'll talk about 15 and how you can do it. Maybe a few different ways. Later you might want to pause on that. Use substitution on 16. 17, use substitution. And on 18, classic use substitution time. And if I'm not mistaken, I am mistaken. Holy cow, this is a long one. I actually did not turn this over. This will be use substitution. I'll make a video with some help later. This one, number 20. Nice thing is there's no bounds. Use substitution. Okay, none of these things are going to be due back that first day I see you, okay? Even when, you know, if we go past the 30th and they become e-learning days or whatnot, you know, SLUs is a different schedule. But I will, as soon as we know when we're going back, then I will let you know the firm due dates. But just do as much as you can with this right now. This is use substitution, so we're going to pause on it. You guessed it, use substitution. 23. Use substitution. This is not an ideal way to learn, but remember, this is exactly what everyone in college is doing right now. So this is actually good prep for you to figure out how you study best. Some of you might be writing notes several times over. I mean, use this to your advantage to figure out how am I going to make it in college next year. I would just do it. Let's FOIL it. First, outer, inner, last. Okay? So you're going to have the integral. Bounds -1 to 2. What is that? 9x squared plus 12x plus 4 dx. Go from there. Here is why we need use substitution. So notice we didn't do any examples when we were doing integration with square roots. And that's when we kind of first learned about the chain rule too, when we had square roots. So we will start early with this one when we do our notes. This is use substitution. Holy cow, and that's all of them. All right, folks, so that is a review video. Some help. Anyway, I'll give you a quiz review number 2 video here soon. And stay safe, everyone. All right, this is Yak Math Videos signing out.